Right, let's carry on from question 6 of the downloaded exam questions. Just for those of you who did this previous section with me, I just wanted to let you know the two graphs that I didn't do for you was the last one. The dry ice was in fact the one that's sublimed with the minus 78.5 melting and boiling point was in fact dry ice. Okay, the one with the that was at 3927 was the boiling point. That is actually boron. Okay, incredibly high boiling points of boron. Okay, right, now let's have a look at question 6. They've given us a table and various sort of atomic structures with element X. For example, they've given us 37, 17, all right, 37, element X, 17. They have asked us for the name, the number of protons, the number of neutrons, and the number of electrons that are in over here, all right? Now, in this case, remember, okay, just to recap, this figure at the bottom, okay, is the number of, let's just write it in over here. This is our protons, right? Protons are there. And that equals the number of electrons, unless it is charged, okay? If it's got a charge, and you'll see some of them coming have got charges on them, right? They means that the electrons are not in balance with the protons because there's a charge on it. Right, how do we do these? What do we do? Well, you go across your periodic table until you find 17, all right? And if you look across, you'll find that number 17 is in fact chlorine. So element X is chlorine, and its symbol is Cl, 1735, right? The number of protons is 17, that's that number there. The number of electrons is 17, same number, that must be equal. Okay, therefore the number of neutrons is going to be what? You take your 37 minus, I wrote a 35, sorry, my bad. 37 over there. The number of neutrons is going to be 37 minus 17, which is actually going to be 20, okay? This is actually an isotope, isn't it? Okay, what's an isotope? We're going to come across another one. 13X, okay? All right? Well, what have we got here? Did I write 13? Okay. Okay. Sorry, guys. I actually wrote that as thingy. I will correct it. Hopefully by the time it gets to you, it is corrected. Just check, what did I actually write on mine over here? I did write 3-1. Sorry. 3x1. All right. What has got one proton? Well, it must be hydrogen 3-1. And it's there. Remember, it had hydrogen, deuterium, tritium. So this is tritium, isn't it? Okay. So what do we say? How many protons? 1. Okay. And there's no external charge, 1 electron. Therefore, I've got 2 neutrons. Okay. This is also an isotope. Okay. It means it's got more neutrons, okay, essentially, than it should have. All right. Let's have a look. 11x and 5. 11x5. What do I do? Let's just let's go through it again. What do we do here? We enter the periodic table and look for element number 5. So you go 1, 2, 3, 4, 5, and we'll see that it is boron. Correct? It's boron. So we enter there and go across until we find the 5, and we can see that it's boron has got 5 protons. 11, so you've got 5 protons, 5 electrons, and therefore we have got 6 neutrons in that one. All right? Let's go carry on up the table here. All right? Just make sure. Yep, I'm there. The next one we said was 8135. So, as I've said before, you look at this 35, go and find number 35 on the periodic table. It's element 35. So you can count 1, 2, blah, 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 until you get to 35, and eventually you're going to get to bromine. Okay? You are going to get to bromine is 35. And over here we've got 81. So 35 and 35. Okay, and how many neutrons? 46. 81 minus 35. 46. Okay. Let's continue. 65x 30. Okay. 65x 30. Go across. 30, and we see it is zinc. Okay, and 70. Whoops. 65. Don't know why I wrote that there, but that's 65. 65. All right. 65. Which means I've got 30 and 30, and on the other side of it, I've got 35. Okay, like so. Then the next one is going to be 20 and 10. All right, let's have a look here. 20, x, and 10. So we enter the periodic table, count to number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We end up with neon, and 20 over there. 10, 10, and 10, right? Which means this is a noble gas. It's inert, correct? The next one has got 3717. Right? We enter with 17, and we go across until we get to number 17. Number 17, okay, is actually going to be chlorine. 1, 2, 3, 4, 5, 6, blah, blah. 17 is actually chlorine. Okay, but what did they have on the outside? I put a minus sign there, correct? Which means this is going to be the chloride ion. Okay? Isn't it? Which means 17, yes. 17 protons, because this is the number of protons. Because in the chemistry and the stuff we do, we don't take the protons away at this stage. When we get to the acids and bases, we donate protons, okay? But here we're looking at this, we say, but hang on. Therefore, I've still got my 20, which is 37 minus 17, okay, there, to get my number of neutrons. But how do I get my number of electrons? I have 1 electron more than protons. Because remember, this is 17 plus, therefore I must have 18 minuses. Because 18 minus plus 17 is minus 1 electron. 1 electron more. See that? Let's do one more. 7031x plus 3. 70x 31. And remember, on top here, I put in a plus 3, I think. Okay? So let's have a look. What is this going to be? Okay? So I go across till I get to 31. All right? This is my protons. At 31, I look on the table which you are, and you are gallium. Okay? And then I go 70 over there, and I note that I have got a plus 3 charge here. So immediately we can say how many protons we've got. We've got 31 protons, 70 minus 31 to get to our neutrons, and 70 minus 31 is 39. Okay? But how many electrons have I got? Hang on. I've got a total charge of plus 31. Right? Now I must end up with 3 more negatives, 3 more positives than electrons. So therefore, I've got to have 28 electrons, right? Because what is 31 plus, okay, and 28 minuses is my plus 3. Okay, I've got 31 positives and only 28 negatives, which means my overall charge is plus 3. Okay, and then the last one I think we have here, yes, the last one is 39x19. 19, we go across with 19 and we see at 19 we've got potassium, but I had a plus 1, okay? So this one, sorry, was the gallium ion, okay? It's the gallium ion. This was the chloride ion over here. So this one I didn't finish. Chloride ion. This is the gallium ion, and this one is going to be the potassium ion, isn't it? Okay, so we go across with the 19 on the table, protons, because that doesn't change. So we say, right, then look, let's see what we've got. We've got 19 of those and 39 on top. Therefore, 19 positives, 39 minus 19 is going to be 20 neutrons. And how many electrons? Hold on. We are plus 1. So I've got 18 minuses. So, but why? Is because 19 plus 18 minus gives me 1 plus. Okay? I've got 1 proton more than electrons. In other words, I'm an electron short, so I am the potassium ion, and you know that potassium is plus 1 if you look on the periodic table. All right? Now, let's move along to question 7. Okay? Question 7, okay, is where we're starting to get assume the following apply to chlorine, 35, 37, and the following apply to sulfur. Calculate the percentage, the relative atomic mass, all right? Calculations of relative atomic mass. Okay. Let's just have a look. Just get up another page here, and page up still. Okay. So what have they told us? They've told us here that we've got this situation, okay? We have got 35 Cl and 37 Cl. Okay? And they tell us the percentage composition occurring naturally or whatever, okay, is 75.77 and 24.23. Okay? Calculate the relative atomic mass. In other words, what you're going to see on the periodic table, right? Okay? Because if you've looked at some of the periodic tables, apart from the one that you've got, you will see that hydrogen isn't 1, it's 1.00 something. Okay? They're not all of them exact. Some of them are, but not all of them are exact. It is because, let's just recap this. It is because in nature we get isotopes, okay? We get some of them have got more neutrons in than others, all right? So we've got that situation where we've got, for example, let's say we've got chlorine, the one we've got now. Most of it, 75.7% of it is Cl35, okay? So it's the normal chlorine. But you do get Cl37, which is the isotope, right? So what do? Well, essentially what we're going to do is we're going to do the calculations as follows, and we're going to put it out, set it out like this, okay? This is the best way to do it, okay? We just get to mine over here. Okay, that's the percentage, right? Now what I do is I say, right, therefore, I convert it to a decimal, and I say 0.7577 times 35. In other words, 75.77% of it is that. So if you think of it as a block, okay, what are they saying? They are saying that 75% of the block, 75.77% of the block is composed of Cl35, right? So therefore, I can take that, and I get that to be 26.52. And 0.0, sorry, not 0.0, it's 0.24. 0.2423 times 37 is going to be equal to 8.97. Okay, so therefore, have a look at this. This is my 24.23%. Is composed of Cl37, right? So in other words, of this block, okay, most of it is composed of 35, so it weighs 75% of the block is 35. So of the total 100%, 0.75 times 35 is the weight of that piece, right? So now we add them together. So, right, therefore the total is 35.49. Okay, therefore the relative atomic mass is going to be 35.5. And if you look on the table, at periodic table, you see Cl 35.5. Right? Okay, now let's have a look at the next one. Right? In the next one, it says here, okay, they've given us it's sulfur. So they've said 32S, 33S, 34S, and 36S. And they've given us the percentages. 95.004, 0.76, 4.22, and 0.016. Yes, that must add up to 100% over there. Okay, so now we change those to a fraction, that decimal. So we say 0.95004 times 32. So it's that times that, right? Because that's the 95% of it weighs 36. It's actually a weighted average. So what do we do here? We say therefore 0.0076 times 33. I'll write the numbers down now. And we get here 0.0422 times 34. And lastly, 0.3016 times 36. Let's put our numbers, 30.4, 0.2475, 1.435, and 0.0058. We add it together and we get 32.1. So the relative atomic mass of sulfur is 32.1. Okay? So this is what we're going to do with all of these here. Right? We're going to put them, each of them, the isotopes, we put down the side here. There like that. Okay? The percentage next to it. Then change the percentage to a decimal and multiply it by the mass of that. Okay? And then that gives us a weighted, and we're going to add them at the bottom to get the effective or the relative atomic mass of the whole block. Okay? Essentially what it is, you've got a whole bunch of atoms, right? All right, you've got a whole bunch of these, but a couple of these. So we take the mass of all of these and add them to the mass of those over 100. Right? That's essentially what we're doing. Right. Now, let's have a look at question number 7. Okay, 8 we've done. Question 9. They want us to say, okay, let's just have a look at question 9. Sorry that I have to flop back. Okay, consider the following electron configurations. Fill in the table the information in the last column. Likely form an anion or a cation or neither. Okay, they have given us all of the electron configurations. All right. So and then asked us, what is it? Is it a metal, a non-metal, or an inert gas? is it going to form an ion, an anion, or a cation? Okay. Well, how do we do this? What do we do? They have given us the electron configuration. So let's just take the first one. 1s2, 2s2, 2p6, 3s2, 3p6, okay, 3d10, 3d10, and 4s2, 4p6. Okay, so now we immediately know it's going to be in row 4, isn't it? Okay, so how do we go about it? Well, let's have a look. If you add all the electrons together, okay, have a look what you get, all right? Add the electrons together, that'll tell us where it is. You know that it's in row 4, okay? Why? Because row 1 has got the first orbital, row 2 the second, row 3 the third, row 4 is the 4th energy state up, right? It's on level 4. Each row across, okay, is going to be the level, the floor that it's on, isn't it? And if you look at it, you can see that this has got a full structure. It's an 8 on the outside. But essentially, you just add it up, and that is equal to your number of protons, which means you've got your atomic number. Therefore, this is going to be krypton. Correct? It's going to be krypton sitting down there like that. Okay? And what are we going to do? Krypton is an inert gas. Right? Krypton is an inert gas, and essentially, okay, does it form an anion or a cation? And it's neither. Okay? Generally speaking, the inert gases don't respond, they don't react, okay? Yes, when you get down to xenon, they have been compounds with it, but you know what? Let's leave it. They're inert. We don't react then, okay? Okay. Let's have a look at B, right? B was going to be, let me just go back to it. Sorry, I've got a flip-flop. 1s2, 2s2, 2p6, 3s2, 3p4, s2. Okay, right. If we look at this, where are we? We are 2 electrons into level 4, all right? Or you just add them all together and make that equal to the number of protons, and then that's your atomic number. And you will see that if you do that, you are at calcium, or essentially you just say, I am at level 4. If I'm at level 4, I must be row 4, 1, 2, 3, 4. I'm at potassium, which I know is a 1, calcium is a 2, so I say that is going to be calcium, okay? And calcium is a metal, okay? And metals form what? They form cations, don't they? Remember, an anion, another negative ion, okay? Another negative ion is there, right? That is what we've got for that, okay? So that's what we say, anion, anion, another negative ion, right? Okay, so she forms that. Next, we've got number C, 1s2, 2s2, 2p5. So we are on row number 2, okay? And essentially, what have we got there? Hey guys, I should have kept my finger in that spot, shouldn't I? Never mind. Okay, we'll get there. Okay, and we said that that was going to be, let's have a look across. We're at floor number 2, okay, because that's where we end, and we've got 7. So lithium is 1, 2, 3, 4, 5, 6, 7. So we get to fluorine. Fluorine, the most electronegative element, the greediest one in such, it eats electrons, so to speak. Okay, so what do? We say, right, what is fluorine going to do? It's a halide, which is a nonmetal. And nonmetals take electrons, don't they? Metals give, okay, they give electrons and the others take, all right? So therefore, it's going to form an anion, isn't it? Which is generally F minus 1. This forms Ca plus 2. Okay? Right. Let's have a look at the next guy. The next one is going to be D, and we can see, oh, hang on, we are at level 3, floor 3, and we've got 2. So we are magnesium, right? See that? Magnesium. It's magnesium. And magnesium is a metal, okay? It forms a cation, and it's Mg plus 2, okay? Right? The next one is going to be, and if we have a look here, we are at level 3, floor 3. So let's go hydrogen, lithium, sodium, that's floor 3. And we go across, because how many do we need to go across? Okay, let's have a look. 8. So we go all the way. So we are at argon, correct? Okay, and this is a gas. Okay, it's an inert gas. Okay, so it forms neither. Okay. Next one, 1s2, 2s2, 2p3. Okay, so we're on floor 2, and we are 5 across. So we go 1, 2, 3, 4. We're at nitrogen. Nitrogen is a nonmetal. It's a diatomic gas. It's N2, isn't it? Okay. And does it form an anion or a cation? It forms an anion, because these take electrons, don't they? So it forms an anion, which means it is going to be, generally speaking, N-3. Okay? That's what we're going to get. The next one, okay, is at level 3, and there's 3 electrons across. 1, 2, 3. Count across. 1, 2, 3. So it is aluminium. The last one is aluminium. Aluminium, okay, it's a metal. Metals give electrons, therefore they're going to be positive, cation, and it's Al plus 3, right? It gives away 3 electrons, it gives away, okay? Right, so that is now getting us to the end of question, question 9, okay? Right. And the next one we're going to do is question 10, which are ionic, polar covalent, pure covalent, and Lewis diagrams, okay? Right. Thanks for watching that. I hope that that's given a bit of insight into the electron configuration and just how we go about these problems. So far, so good. Cheers. I'll see you in the next one. Bye.